Different ways to call functions. There are two most popular ways to call functions for parameter passing. Call by value. This method copies the value of an actual parameter into the formal parameter of the function. Both actual and formal parameters are stored in different memory locations. So, any changes made to the formal parameters in the called function are not reflected in the actual parameters in the calling function. By default, C programming uses call by value to pass parameters. Let's write a simple program to swap the values of two variables using a third variable to demonstrate call by value. Create a new file in code blocks and save it as s7_02.c. File, new, empty file, press Ctrl S to save the file s7_02.c. Click save. Quickly include the header file stdio.h. Write the main function int main open close parenthesis void as parameter open close curly brace return 0 semicolon. Let's declare the swap function before main. Void swap open close parenthesis int x comma int y semicolon. You can put a new line here for better readability. Next, inside the main, define two integer variables. Int a equals to 100 semicolon int b equals to 200 semicolon. Print the values of a and b on the console before swapping. Printf open close parenthesis semicolon within double quotes write before swap comma value of a colon space %d \n comma a. Printf open close parenthesis semicolon within double quotes write before swap comma value of b colon %d \n comma b. Call a function named swap to swap the values. Swap open close parenthesis semicolon a comma b. We have passed the values of a and b to the swap function as parameters. Next, print the values of a and b after calling the swap function. I will just copy these two lines and paste here, and I will change this to after. Next, after main, write the swap function definition to swap the values. Void swap open close parenthesis int x comma int y open close curly brace. Declare an integer variable called temp int temp semicolon. Save the value of x in temp equals to x semicolon. Put y into x equals to y semicolon. Put temp into y equals to temp semicolon. Print the values of x and y from swap. I will just copy these two lines and paste here. After swap value of x, also change here, and this should be y, change here. Alright, press F9 to compile and run the program. Build and run. Before swap value of a is 100, before swap value of b is 200. After swap value of x is 200, after swap value of y is 100. after swap value of A 100 and after swap value of B is 200. Perfect. Here first we print the values of A and B on the console before calling the swap function. So the values 100 and 200 gets printed out for A and B respectively. Then we call the swap function with the values of A and B, the actual parameters. The formal parameters of the function x and y receive these values. After swapping x and y using a temporary variable called temp, we print the values of x and y. This time 200 and 100 gets printed out for x and y respectively, which shows that x and y has been actually swapped inside the function. Finally, we print out the values of A and B, get the output of 100 and 200 respectively, which are the values of A and B before calling swap. This shows that the effect of swapping formal parameters in the called function does not change the actual parameters in the calling function. Notice that I have used the void keyword instead of using an empty parameter list in main. An empty parameter list in C indicates the function is taking an unspecified number of arguments of unspecified type. In the case of C++, an empty parameter list in either a declaration or a definition indicates that the function takes no arguments and is equivalent to using a parameter list of void. So, if a function is not meant to take any parameters, specify that by using void in the parameter list. That is the correct way to say no parameters in C, and it also works in C++. Call by reference. This method copies the address of an actual parameter into the formal parameter. Both actual and formal parameters refer to the same memory location. So, any changes made to the formal parameters in the called function are actually reflected in the actual parameters of the caller. In C, we can use pointers to get the effect of pass by reference. For example, we can write the same program of swapping by passing the addresses of actual parameters to show that it affects the values of actual parameters outside the function as well, unlike call by value where the changes do not reflect outside the function. Recall our discussion of address of operator called ampersand, which is used to get the address of a variable of any data type. This is also referred to as reference operator. For example, scanf function uses this operator. When we say ampersand A in its parameter, we are telling scanf at which memory location it should store the value entered by the user from keyboard. Just like scanf, in any function call, we can pass this address of actual parameters so that it can be modified using its address. So accordingly, you need to declare the function parameters as pointer types using the other pointer operator called value at address operator star or asterisk, which is used to access the value at an address. This operator is also referred to as dereference operator. For example, an integer pointer variable j to store the address of an integer variable I is declared as follows: int star j semicolon, and it can be assigned with the address of I as follows: j equals to ampersand I semicolon. Let's write the same program for swapping two variables in a different way to demonstrate call by reference. Open s7_02.c in code blocks and save it as s7_03.c. File, save file as s7_03.c. Click save. Alright, edit the function declaration like this: void swap int star x, int star y. While calling the swap function, we need to pass the address of A and B. So write ampersand A, ampersand B. Edit the function definition to swap the values using call by reference. Void swap, within parentheses write int star x, int star y. Here change this to star x, change this to star x, change this to star y, and change this to star y. Also, we need to change here, this should be star x and this should be star y. press F9 to compile and execute the program. Build and run. Here, first we print the values of A and B on the console before calling the swap function. So the values 100 and 200 gets printed out as usual. Then we call the swap function with the addresses of A and B, the actual parameters. The formal parameters of the function *x and *y receive these values. After swapping x and y using temp, we print these values. This time 200 and 100 gets printed out for x and y respectively, indicating x and y has been swapped inside the function. Finally, we print the values of A and B and get the output of 200 and 100 respectively. This clearly shows that the effect of swapping formal parameters in the call function has reflected outside the function as well, unlike call by value where the changes do not reflect outside the function. A detailed discussion about pointers will be given in a later section. Thanks for watching and see you in the next video.